I don't have time in here, nor would there. It would be kind of complicated to teach how to read a SKUT log P diagram where the sounding is plotted, but it's very useful to learn that. SKUT log P diagram tutorials are on the web, and it's you learn to read a SKUT, especially since we have an Oakland sounding, which is very close. No, they're about 200 miles apart, so here we're pretty fortunate to have one this close. The next one over is in Reno. Then we got one up in Medford, and then you got to go, I think, down to Vanburg, I believe, is the next one south. So they're pretty, you know, it's a pretty course. They're pretty far apart. There's about 100 launched in the U.S., about 900 worldwide, but it helps the weather models just see what the wind is doing. But being close to one, if your flying site is close to a sounding, it's worth taking the time to learn to read a sounding, because then it's one of my quick links on my phone. I'll pull it up, and I can see the fingerprint of a good day. I can quickly see here how deep is the marine layer, what are the winds above it, what are the winds within the layer. Is, you know, quickly pulling up a sounding at work. I can see, okay, I'm not missing anything today. Like, oh no, I wish I was flying. So that okay. When it comes to since a lot of the stuff that we fly in is not resolved, a lot of it is not actually even like truly scientifically understood exactly how it behaves. I mean, the closest we can come to seeing thermals is they sometimes use a LiDAR, which is like a laser that scans back and forth like this, an ISAC laser that goes out about 8 kilometers, and it picks up, you know, you can see the differences in the fine dust particles, and there's animations of that, and you can actually kind of watch thermals, you know, throughout the day start to come on. And what thermals are is it's convection. It's kind of the air starts to boil, and you know, heating from the bottom or cooling from aloft. If there's colder air moving in aloft, both of those things promote thermals, and vice versa. If the bottom stops heating, then the thermals start shutting down. Or it can be very hot. It can be a very hot blue day, but if there's warm air moving in over the top, you're warming from the bottom and the top. It's just getting hot, hotter and hotter, but there's not that great a thermal. So keep in mind that it's a push-pull situation. So in general, wind, you know, kind of general rules to think of, wind usually increases with height. The big exception to that is valley winds. You can have a very light, kind of benign synoptic day. There can be big high pressure sitting over the area, and somewhere up in a mountain launch, you can be 11, 12 o'clock, and there's no wind, barely a few cycles coming up launch. And the valley winds can already be just honking really strong, just because it's, you know, on those days, often when it's really clear and sunny out, you develop a heat low in the mountains, and it starts to draw in a lot of air through the valleys, and it can be very windy in the landing zone. So that's where an exception to the rule of wind increasing with height. It can be perfectly launchable. Looks like there's no issue with launching on launch, and it can be quite windy in the landing area. So if you can have any kind of information on that wind, or call somebody in the valley if you're not sure, that's good. If it's a totally unknown place, if you're there alone or something, you might just want to be aware of that. There's a place I remember back in the 90s in Venezuela. It was called La Trampa, the trap, translated, and it kind of was a trap. I mean, it was exactly what I was talking about. Very light cycles on launch, and you'd be going backwards by 11 o'clock in the LZ. You'd have to set up your landing almost backwards if you launched at that time. So just have to be something to be kind of keep in mind. Also, in general, within the troposphere, temperature decreases with height, but then there's inversions. Here it's very pronounced with the marine layer. It can be an inversion of almost, on some days, of almost 20 Celsius. Air gets, you know, a lot warmer above a certain height, and that pretty much acts as a lid to the thermals. Now, I like to think of an inversion as kind of a trampoline from the bottom, and like thermals can be like hyperactive kids under the trampoline, and their head hits it every now and then. You would see that surface, you know, bounce up a little bit, but they get forced back down. So it's not a hard surface, and depending how pronounced the inversion is, is how far up a thermal might push up into it. You sometimes feel in some places you're thermaling, and you feel like maybe you've broken through it for a little bit because you're, often down in the layer, get pollutants accumulate, and it's kind of, the air is kind of hazy, and you get above it and you kind of see the blue sky for a moment. But you might just be in an overshooting thermal that's already now just running out of steam. It's it's moving on momentum, but it's already negatively buoyant, and you'll soon bop back down. When you hear of people breaking through inversions, or usually that if a thermal is breaking through an inversion, which you sometimes hear about, that really means that locally at that place where that happened, there wasn't that much of an inversion left. It was probably a pretty strong thermal, but it wasn't a very strong inversion left, because thermals don't break through strong inversions, or it might have been just a very skinny height-wise inversion. But it is possible you could still have a pretty strong inversion over the valley, and then over the slopes it's kind of eroded away, and then you can kind of get up to the next level. So sometimes people bench up to the next level where everybody's left flying and below a certain level in the valleys, and it's just because the way along the slope they were able to kind of get through it in a certain localized area. There wasn't much of an inversion left. Convergence, when wind wraps around a certain feature, usually nice convergences where it's a fairly large feature and the wind is channeled and kind of hits itself, and then it has nowhere to go but up. Now you can get convergence or you can get confluence. You can have confluence, it kind of comes together and it doesn't really go up, or there's, in general, a really strong capping inversion won't let it go up. But often if there is a convergence, I've found it's kind of the most elusive kind of lift, where you don't, unless you know that place and it comes in like clockwork and you can kind of learn where it is down. I haven't flown in Elsinore personally, but I know they've got it kind of, they know, they've flown it long enough to where they know where it comes in at what time, under what conditions. Sometimes you stumble upon one. Sometimes looking at the topography and looking at which way the valley winds go, you can kind of see a place where one should occur. And I've found often they slant. When the winds slam each other, rarely are they exactly the same strength. It's rarely the textbook together and straight up. It's more of one stagnates the other and creates a bit of a ramp. So you would see the wind in a convergence often going up at a little bit of an angle rather than totally straight up. In feeling wise, it gets manifest often like extra thermals in that area. Often you can, in the area of a convergence, you get up higher than you would in thermals in general, in that, like on that day. So it's an area that kind of enhances, feels like enhanced thermals, and it's one of those things that takes a while for. It often happens, under the same. If it's high pressure, which I'd call it synoptically benign, clear skies, same time of year, things tend to happen on schedule because the Earth is receiving, the same amount of heating throughout the day. It's kind of, things tend to kind of, happen on schedule. So in those situations, valley winds will come on at the same time, and then convergence, if it's occurring, might set up at a certain place and might either hang in that place or migrate. Like I said, rarely is one wind exactly the same strength as the other as they hit each other. So it might start somewhere and then move along. Also, what I've found under a convergence is often the air is fairly right there on the ground is an area, like if you're driving around and you see you're driving somewhere and the wind's been coming from this lake and coming around and it's pretty windy, and then you drive through a calm area and then it's coming from the different direction. So often under the convergence, and like I said, they're slanted, so it might not be directly underneath it, but at the surface part of the convergence, it's quite calm because the wind has kind of negated each other. It slammed itself and it's now being forced to go up. And sometimes if it's quite windy, now this is kind of an advanced thing, but that might be the best place. If you have to land or if you want to get out of the sky, you might have this strip of very calm wind where it's quite windy on one side, quite windy on the other side, and right there, of course it means getting down through the convergence, it means getting down through a lot of lift. But
I'm just going to jump in here for a second. I'm going to talk about the specifics
Okay. What I wanted to talk. Let's see. Where was that? Okay. Just a second. Convergence. Okay. Stability. Okay. So understanding thermals, like I said, you have to. Thermals are basically the air's gotten less dense and more buoyant than its surroundings. So it's unstable. It wants to go up. That is the sort of, if you think of the depth from the ground to where the thermals top off, we call that the boundary layer. It's got the surface layer, the mixed layer, and then entrainment zone. The surface layer is where the air is being heated, the ground is being heated by the sun, which in turn heats the air. It creates a large kind of pool of extra warm, buoyant air. If it's on the flats, it can kind of hang there for a little bit. If it's on a slope, rarely will more buoyant air just doesn't hang still on the slope side. It'll start to develop a slope flow. Just if you're more buoyant, if you get less dense than the surrounding air, and you're on a slope, you're naturally just going to start flowing up the slope, which often draws in air from the flatter areas. That is also more buoyant, and things tend to ride up the mountain. So if you have terrain features, it's just natural that it's more likely that you're going to find the rising air above a raised feature like a mountain or a hilltop than out over the valley. It's not that the air isn't heating over the valley, but it just naturally flows towards that mountain. It's kind of the idea, almost the fact that it's not flowing from the mountain because there's a physical mountain there. It's the idea if you're around the campfire, and especially if you're the only person around the campfire on a still night, no matter where you move, you kind of find that the smoke tends to go towards you. And part of that is because you're blocking that. It can flow from all sides, but from where you're standing. So it feels like the smoke keeps chasing you around in an annoying fashion. But that's kind of how you can think of, like, thermals will tend to track up a mountain face because there's no wind coming directly from the mountain itself. So everything, the natural slope flow by the mountain face is pulling things in, and then it'll draw in air from the flats. That's not to say that you can't have a small bump out front, set off a thermal somewhere out front. And often the best thermals might not track their way all the way up to the mountain. They'll come off the knolls out front, because if you have to think of source areas like if it's a really large area that's heating, that's your source area for that thermal, and then you have to think, okay, where's that gonna trigger off? So, for example, Slide Mountain, sometimes it makes sense to fly out and commit to going out over the knolls. There you encounter the thermals higher up, because right near the terrain, it's sometimes hard to catch a thermal unless it's a really strong one. Once it's been up above the terrain, it's usually sometimes several thermals converge on, almost like roots of a tree to a trunk, and then you can get the thermal out further and above the knolls. And that's, I started in the Bay Area, started doing, in the 90s, a lot of ridge soaring, and that's a really hard thing to do, is to leave, like, if you can just barely maintain on a hillside, you want to kind of, the tendency to soar next to something that's working, and the commitment to risk sinking out and head out and hope to encounter the thermals that are coming off the knolls or off the features for more out in front. But often that's what's necessary to get the really good thermal.
Let me jump in here just a second, into the Bay Area. If you look up here, typically we have a west to northwest flow typically. Usually we'll fly south a little bit. On the lee side of every little knoll, you usually have a little thermal bubble kicking up. So what Hans is saying, instead of staying on the windward side, you look, yeah, you're staying where you are, maybe in zero sync with a little more. But if you want to go for it, just go. If you go, you'll probably catch that little lee side thermal going up. It's like a little bubble, and you'll stay in that, and as you go, you'll get another one, and they'll converge, and you get maybe three, and now pretty soon you have like a trunk of a tree going up, and now you're styling going down. So every lee side of every little ridge here usually has